All right, completing the square, and this is going to be completing the square Algebra 2 style. So we will include some complex number solutions, and you're going to look at both situations when your leading coefficient is 1 and when your leading coefficient is not 1. So first, completing the square and writing in factored form. So the whole idea behind completing the square is that you want to make the left side of the equation a perfect square trinomial. So what you do is you take half the coefficient of the x, which here would be 6, take half of that, and you square it. So half of 6 is 9, and so you square that and you add it to that trinomial. When you do that, it factors to x plus 3 times x plus 3 because 3 and 3 multiply to 9, and 3 plus 3 add up to 6. So we get this perfect square trinomial, and it equals x plus 3 squared. That's the whole idea, is to manipulate the left side so that we get a perfect square trinomial. We can write it as this perfect square piece and then solve by square roots after that. So let's just practice finding and completing the square here, a couple of them. So, whoops. Can't remember which one's which here. Okay, so this is the first one, and you have x squared plus 12x plus blank. So you take half of the middle, which would be 6, and then 6 squared is 36. And then that factors because if you think about in your x, 36 adds up to 12. Well, that's 6 and 6. Multiplies to 36, adds up to 12. So this would factor to x plus 6 times x plus 6, or x plus 6 squared. All right, the next one here, y squared plus 14y. Half of 14 is 7, and 7 squared is 49. So that's what would make this a perfect square trinomial. Now this perfect square trinomial should factor to factors of 49 that add up to 14 would be 7 and 7. So factors to x plus 7 and x plus 7, or x plus 7 squared. Hopefully you're starting to see a pattern here. Half of 12 was 6, it factored to x plus 6. Half of 14 was 7, it factors to x plus 7. Here, half of negative 10 would be negative 5, and negative 5 squared would be 25. Factors of 25 that add up to negative 10, well, that would be negative 5 and negative 5. So it's going to be x, or I guess it's a y minus 5 times y minus 5, or y minus 5 squared. So again, half of negative 10 was negative 5, and it factored to y minus 5 squared. So hopefully you're seeing a connection there. The bottom one is a little bit trickier because it is a 5 here, and so when we take half of 5, we end up with 5 halves. And we want to leave that as a fraction so that we come up with the exact answer. And 5 halves squared. Now when you square a fraction, you can go ahead and square the top and square the bottom separately. So that's actually going to be 25 fourths there. And now if I want to factor this bottom piece, you have to think, well, what are two numbers that multiply to 25 fourths but add up to 5? Well, that's 5 halves and 5 halves. Really, that's 2.5 and 2.5. 2.5 times 2.5 multiplies to 25 fourths, and it adds up to 5. And 5 halves times 5 halves is 25 fourths. So then this one factors to x plus 5 halves squared. So we see the connection with whatever our b divided by 2 is becomes our factor in our perfect square, and we can rewrite that. Our b here, b divided by 2 is negative 5, it's negative 5 here. B divided by 2 up here was 7, it was 7 here as well. Another thing to note is that when you have a minus in your trinomial, you have a minus in your factors as well. If your trinomial was a plus here, it's going to be a plus over here as well. All right. Here are the rules for completing the square, and this will make more sense once you see a couple of examples done. But very important in order to start completing the square, you have to make sure that your a is equal to 1. Remember, your a is your leading coefficient, your number in front of your x squared. So if it's not equal to 1, you'll have to make it equal to 1 using division. We have to write the equation so that c is on the right side of the equal sign. So we're going to have to move the c over to the right side, either using subtraction, addition, or subtraction, depending on the sign of c to begin with. Then the complete the square part is adding. You take half of the middle term, the b, and then you square it, and you add that to both sides of the equation. Then you write it as a perfect square, and remember that it's always whatever your b divided by 2 was squared, and you write that equal to some number, and then you end up solving it by square rooting both sides and solving from there. So let's look at a couple examples. Here's the first one. All right, so first we have to make sure that a is equal to 1. Our leading coefficient is equal to 1 because it's 1x squared minus 6x minus 16, so check. Next was move c to the other side. So it's a negative 16, so I'm going to add 16 to both sides. Keeping in mind my next step is to take b divided by 2 squared and add that to both sides. So in this step, I'm going to add my plus blanks. I like to add a plus blank here, and then 0 plus 16 is 16, and plus blank there. In these blanks is where the b divided by 2 squared is going to go. Here b is negative 6. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So 9 is what goes in those blanks. Then I can factor this left side here, and factors of 9 that add up to negative 6, well, that's going to be negative 3 and negative 3. Again, it happens to be the b divided by 2. So this will factor to x minus 3 times x minus 3, which I want to write as x minus 3 squared. Over here, I'm going to combine like terms. 16 plus 9 is 25. Then I can go ahead and solve by square roots, which is a previous lesson that we have talked about. So to get rid of the square here, you square root both sides. That's the inverse operation. This square root will take out this square, and on the left, you're left with just x minus 3. Equals, the square root of 25, remember, is plus or minus 5. Then the last step to get x by itself is to add 3 to both sides. Just be careful at this step because remember you have 5, positive 5 plus 3 is 8, or you have negative 5, and negative 5 plus 3 is negative 2. So notice 5 and 3 are both real numbers, so we can add them together. So we have two answers, x is either negative 2 or x is 8. And then remember, if we want to draw it back to our quadratics, go back up to the beginning, we solved this. This is a parabola. It opens up. These are my x-intercepts. These are my solutions. So at negative 2 and 8, that's where it's crossing the x-axis. So those are your x-intercepts, solutions, roots, zeros. They're all interchangeable names there. All right, so a equals 1, check. X squared plus 4x plus 6. Next is to move the c, which c stands for constant, so it's the one without the variable. So we're going to move the 6 over. And I get x squared plus 4x plus blank equals 6 plus blank. Remember, I leave the blank so I can add the b divided by 2. A, b, c. So b divided by 2 will be 4 divided by 2, which is 2, and 2 squared is 4. So that's what goes in those blanks. I like to add the blanks again to remind me that whatever I do to the left, I also have to do that to the right. Now we just simplify the left by factoring. So factors of 4 that add up to 4. Well, 4 is 2 times 2, and 2 plus 2 is also 4. Remember, it has to multiply up here and add 2 down here. So 2 times 2 is 4, 2 plus 2 is 4. So it factors to x plus 2 times x plus 2. And I want to write it as x plus 2 squared. Then 6 plus 4 on the right is 10. From here, I can square root both sides. That leaves me with x plus 2 on the left, and plus and minus the square root of 10. Note that the square root of 10 is 5 times 2, and 5 is prime and 2 is prime, and so there's no perfect squares under the radical, so I leave it as just plus or minus the square root of 10. Now to get x by itself, you can subtract 2 from both sides. You get x equals, now 2 is a rational number and 10 is an irrational number. So we can't really combine them in the form that they are. We would need 10 to be an approximation for a decimal in order to add those together. So instead, we put the negative 2 out front, and we do plus or minus the square root of 10. This really is two answers. It's negative 2 plus the square root of 10, and negative 2 minus the square root of 10. The square root of 10 is approximately like 3.1. So you could say that, approximately this is negative 2 plus 3.1 would be 1.1. Negative 2 minus 3.1 would be negative 5.1, approximately. Remember, these are your x-intercepts. This was a parabola that also opened up to just give you an idea of coming back to what these solutions mean for us. In Algebra 2, we do want to leave our answers in exact form, so this is the form that I'd like you to leave it in. I'm going to come back to that example in just a minute, and I'm going to do this one first. So here, does our A equal 1? It does not. A, in fact, equals 3. We need to make A equal 1, and we're going to make A equal 1 using division. So I can divide 3 by 3 and get a 1x squared. If I do that, I have to divide everything by 3, just to keep the equation balanced. So I'm going to get x squared. 12 divided by 3 is 4x. 60 divided by 3 is 20, equals 0. Now, go next to the next step. A equals 1, move C. It's positive 20, so to move it to the right, I'm going to have to subtract 20. Get x squared plus 4x plus blank equals negative 20 plus blank. In those blanks, that's my B, which is my 4 divided by 2 squared. It's going to be 2. 2 squared is 4. Over here comes a 4, 2. Factor the left side here. Factors of 4 that add up to 4, that's the 2 and 2 again. It's positive here, so it's positive in your factors. So x plus 2 times x plus 2, or x plus 2 squared. Now, combining like terms over here, negative 20 plus 4 is negative 16. So when I square root both sides, I'm going to end up with x plus 2 equals, remember that the square root of 16 is plus and minus 4. The square root of negative 16 is plus and minus imaginary 4, or 4i. And then we're just going to subtract 2 from both sides to get x by itself. And just like with the rational number and the irrational number, this is a rational number and an imaginary number, or a real number and an imaginary number. And when we put those together, we make what's called a complex number. And so we want the complex number to be in standard form, so that's the a plus bi. You want to write it with the real part that comes first. And when we get an imaginary answer, when we're dealing with quadratics, that means that when we look at the graph of the parabola, it doesn't cross the x-axis. So there are no x-intercepts for this particular quadratic equation, if we were tying it back to the graph again. So we still have answers, but these answers are complex roots. All right. Save the best for last, and I say that because this one's a little complicated because it involves some fractions. But this is an important example to pause and try on your own and maybe go back and watch it one more time. So first we have to have a equal 1. So like in the last one, a was not 1. That's going to leave me with x squared minus x. And then, So if negative 4 divided by negative 4 is x squared, 4 divided by negative 4 is negative x, 2 divided by 4, that's actually negative a half, equals 0 divided by anything is 0. So be careful there. We're going to leave it as a half. I'm going to add a half to both sides because it's a negative a half. Now I'm at x squared minus x. In the moving c step, I add my plus blank, and I get 1/2 plus blank. Then I take my b divided by 2, square it. So a, b, this is my c term over here. So b, it's a negative x. That's really like I have a negative 1x. So if I take that negative 1 and divide it by 2, I get negative a half. And if I square negative a half, it's going to be negative 1 times negative 1 is 1. And 2 times 2 is 4. So negative 1/2 squared is 1/4. 1/4. Now remember, just like when we did the last one, whatever you get in your b divided by 2 part, this part is always what you end up with in your parentheses. So don't overthink it too much when you're doing this one. When you want to factor the left side here, you need factors of 1/4 that add up to negative 1. But you already have it right here. It's negative a half. Negative 1/2 times negative 1/2 is positive 1/4. Negative 1/2 plus negative 1/2 is negative 1. So the left side here factors to x minus 1/2 times x minus 1/2, or x minus 1/2 squared. Now over here, to combine like fractions, you will need a common denominator. So 1/2 and 1/4 have a common denominator of 4. So to change 1/2 to 4ths, you multiply both the numerator and denominator by 2. So we get 2/4 is the same thing as 1/2 plus 1/4. 2/4 plus 1/4 is 3/4. Now you can square root both sides. And when you square root a fraction, remember you should square root the top and the bottom separately. Over here, you're left with x minus 1/2 equals, square root of 3 is irrational, so we leave it as the square root of 3. The square root of 4 is 2. Last step would be to add a half to both sides. And that's going to leave you with x equals 1/2 plus or minus the square root of 3 over 2. Since the square root of 3 over 2 is irrational, I'll just add the 1/2 to the front here. Let me see if I can make this fit the whole example. Fit to height here. So you can see kind of the whole thing, and you can pause it here if you'd like. So we ended up with the fraction and had to square root both sides, square root the fraction. And the answer becomes awfully complex. Now that's where I stopped in notes today for class, so you can stop here if you'd like. I do have just like one more example I was thinking about doing here. And so this is the one that, the last example I added in for the video, but I didn't do it in class today. So the reason I chose to do this one is because you can notice that the b term is, the bx term is actually on the right. So we need that over here, and we need the c term over here. So in order to rearrange this a little bit, I'm going to have to subtract 10x and move it to the left. So you get 5x squared minus 10x plus 20. Then I need to move my c over to the right. So this one required a little bit of movement before you can even begin, because you want the c on the right and you want the b term on the left. Then your a must be equal to 0 or equal to 1, so you will need to divide everything by 5. All right, this whole example will stay now. So x squared minus 10 divided by 5 is 2x plus blank equals 20 divided by 5 is negative 4 plus blank. Then negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. So I'm going to end up adding 1 to both sides. Then factoring the left side, well, factors of positive 1 that add up to negative 2, that's going to be negative 1 times negative 1 is positive 1, and negative 1 plus negative 1 is negative 2. So this factors to x minus 1 squared, and negative 4 plus 1 is negative 3. Can square root both sides here, and we get x minus 1 equals, so the square root of negative 3. So that's actually plus or minus imaginary square roots of 3. So I square roots of 3. Finish solving it by adding 1 to both sides. Remember, you want to keep your real part out first, and then your imaginary part will come next. So your final answer will be 1 plus or minus I square roots of 3. Okay, that's all I have for you. Thanks for watching.